You know, it's only been about 80 years since we began to realize just how big the universe really is. It was in the mid-1920s that astronomer Edwin Hubble identified variable stars in a spiral structure called Andromeda, and thus proved it to be an entirely separate galaxy from our own Milky Way galaxy. Hubble then went on to discern that just about every galaxy is moving away from just about every other. And it's only been in the past few years that the orbiting space telescope named after Hubble has helped to show us that not only is the cosmos expanding, it's doing it at a faster and faster rate. Well, here to enlarge our picture of the universe even further is astronomer David Lekron. Certainly a big question on many people's minds now that the technology has been improved, the cameras are better, the pointing and tracking is better. Any chance of actually getting images of planets around other stars?
Now, it is something of a holy grail to actually spot a real planet, to actually take an image of a planet. And by that, I don't mean take a picture of a disk. Hubble does not, even with all its clarity of image quality, it doesn't have the resolution to actually resolve the disk of a star, let alone the disk of a planet. But we can detect planets as points of light nearby to the bright stars around which they're in orbit. The certain thing we can do is to detect the environments in which planets exist and detect the material from which protoplanets or young planetary systems would be formed. And I think it's more important for Hubble to start to understand the physical mechanisms that lead to the formation of planets and the different kinds of architectures that planetary systems can take on and why they take on those forms. What we're discovering is that sometimes it's not easy to form planets because the nearby environment is so hostile. So we're trying to understand under what conditions planets could form and under what conditions they could not. And by doing this kind of background work, we're laying the scientific foundation for future NASA missions that are specifically designed to image planets, to detect Earth-like planets and image them ultimately, or at least determine whether they can be habitable or not. These are pretty far in the future, but we've started the work. This is one of those areas where Hubble has surprised us with what it's able to do. It's certainly able to do more than we ever expected in this area when it was launched in 1990. And so I think the science of planetary systems is off on a strong footing, and Hubble Space Telescope is responsible for that.